Let's review some of the stuff we tried to learn today. So we had this triangle here, and this angle was 11 degrees. Now, any time you have an angle of 11 degrees, you have this kind of slope triangle kind of thing, where you have a right angle, and it's always rise over run 1 over 5. So the change in y over the change in x. In other words, you guys have done stuff like this. So here's rise over run. Rise over run. So you would end up with a fraction of 1/5. So this angle right here is always connected to this fraction, always, when we're looking at these two sides, rise over run. Okay, now what if we wanted to look at that other angle, which is up here, right there? Well, if this is 90 degrees, and if this is 11 degrees, you add those two together and subtract from 180, and you end up with 79 degrees. So this angle is 79 degrees. Well, what fraction is connected with that? Well, you might want to just look at it like this. Oh, okay. So now the rise and run is 5 over 1. So this is now the up and down part, and this is the side-to-side part. So it gets kind of flipped. So let's go back the other way. So in other words, if we were looking at 79, it would be 5 over 1 is connected with this one. So this angle, 79, is connected with 5 over 1, and this angle, 11, is always connected to 1 over 5. That's kind of what we were trying to learn today. Let's look at something else we were trying to learn. Now the next problem says, what if we graph this line, 2 over 5x? Now I'm hoping that you remember how to do this. You start at 0, because this is really 2 over 5x plus 0. Y equals mx plus b, where this is our b, which means that we cross at 0. And then we say, well, what if we go over 5 and up 2? Over 5 and up 2. I'm just kind of sketching this. Or you could say you go up 2 and over 5. Either way, you do end up at this point, basically. So now I'm going to try to draw this line. And there's the line. And we have this slope triangle, which kind of looks like this. It goes down 2 and over 5. Now, those values, 2 and 5, so our slope triangle is right here, 2/5. And we wonder, what angle does that associate with? Well, it turns out that that angle is 22 degrees. So if you measured it, it would be 22 degrees. And so anyway, the angle 22 degrees is going to be connected to 2 over 5. That fraction, they're associated in some way. Now, also, you might want to say, well, we did what we did. You know, the other problem, we figured out what this one was. And we could do that very quickly. We say 90 degrees and 22, and what's left over for 180? Well, that would be 68. So this angle in here is 68 degrees, which we could say, if you related it to the first problem, oh, okay, so then we can flip it and say then 68 degrees has to be associated in some way with the slope triangle of 5 over 2. Don't forget, we could kind of spin it like this. So now we got 68 degrees is right here, and we look at rise over run, up and over. Okay, so that's one way to look at it as well. So let's turn that back. Like that. Okay, let's look at the next thing. Now the next one says, why don't you just draw an angle of 18 degrees? Which is what I did. I used a protractor, and I put the protractor at the end of the line here, line it up with 0, and look, that line I drew right at about 18 degrees, and I just continued that line out like that. So that's how I did that. 18 degrees. Let's see. 18 degrees. And the question really is, what is this rise part and what is the run part? And that would be our slope triangle, which would be associated with 18 degrees. So we're going to do that a lot. We're going to associate with these fractions, these side lengths that we compare to these angles. So it kind of makes sense that as this angle gets bigger, the fraction gets bigger, I think. But I think we're going to work with that a little bit next time I see you. Anyway, that's enough for right now, and thanks for watching. We'll see you next time.